Most AI agent tutorials obsess over the model. Automation behaves, they compare model benchmarks, they argue about which model reasons better, they show a prompt, connect one tool, call the result an agent. But the model is not the agent. The model is only one component inside a larger system. A real agent needs reasoning, but it also needs memory, tools, planning, guardrails, validation, and a way to keep track of what happened. If you only focus on the model, you can build something that behaves impressive in a demo and still fails the moment it touches a real workflow. That is the difference this video is about. Automation behaves. We are going to break down the core components of a real AI agent and use a cybersecurity example to show why each layer matters. B behaves because in production, the question is not just can the model answer, the question is can the system move work forward safely with evidence, controls, and reviewable output. A chatbot can be useful with a model and a prompt. A real agent needs more than that. Behaves. Think of an agent as a workflow system with a reasoning layer inside it. It receives input, decides, behaves what should happen next, uses tools, updates state, checks risk, and produces an output that can be reviewed. That means the architecture matters. If the agent has no memory, it loses context. If it has no tools, it cannot change workflow out of behave state. If it has no planner, it may call the wrong thing at the wrong time. If it has no guardrails, it can take unsafe actions. If it has no validator, nobody knows whether the output is complete grounded or policy compliant. This is why so many demos look good but fail in real environments. Automation behaves. The demo shows the model talking. Production tests whether the full system works. Omni behaves. So let us walk through the 6 components that matter. The first component is the LLM or reasoning layer. The automation behaves. So this is the part most people already understand. The model interprets the task, summarizes information, compares options, explains trade-offs, and generates structure output. Automation behaves. In a vulnerability triage workflow, the reasoning layer might read a scanner finding and explain why it matters. Behavior might recognize that an internet-facing VPN issue is more urgent than an isolated workstation issue. It might explain why active exploitation changes priority. Useful. But reasoning alone is not enough. Automation behaves. The model does not automatically know whether the asset owner changed yesterday. It does not automatically know whether automation behaves and the vulnerability is already ticketed. It does not automatically know whether the patch window is frozen. Behaves not automatically know whether company policy allows the next action. How the LM is a reasoning engine, not the whole machine. And automation behaves. If the only component you have is reasoning, your agent can explain work better than it can perform a work. The second component is memory. Memory is what allows the agent to retain useful context across steps, tasks, and decisions. Automation behaves. This does not mean giving the agent unlimited memory or letting it remember everything forever. In production, memory should be purposeful. It can include prior decisions, current case state, known asset ownership, risk policy, previous reviewer feedback, and recent find of. An automation behaves. Security workflow memory helps the agent avoid treating every event like it is brand new. Automation behave. If the same vulnerability appeared last week, memory can help connect the cases. If a reviewer corrected the automation as owner for an application, memory can help prevent the same mistake. Policy says production systems require approval. Automation behaves. Memory can keep that boundary visible throughout the workflow. Without memory, the agent becomes inconsistent. Automation, it may repeat work. It may lose the reason for a decision. It may contradict itself across steps. Automation behaves. It may forget that something already failed and try the same broken action again. Memory is what turns isolated model calls into a continuous workflow. Third component is tools. Team behaves. The tools are what let the agent interact with the world outside the model. Help me in reading scanner output, querying a CMDB, checking exploit intelligence, searching tickets, posting to Slack, drafting a JIRA issue, or creating an approval packet. Team behaves. Tools are where an agent starts to become operational. Tools also increase risk. Behaves. A tool can return stale data. A tool can time out. A tool can partially succeed. A ticket. Automation can be created but fail assignment. A search can return incomplete results. An API can change its response. Automation behaves format. That's why tools need structure. The automation behaves. The agent should know which tools are allowed, what each tool is for, what success looks like, what failure looks like, and what to do when a tool returns uncertain evidence. A real agent does not just call tools randomly. It uses tools inside a defined process. For a vulnerability triage agent, the tool layer might collect scanner findings, asset ownership, exposure, status, exploit context, ticket history, and maintenance windows. Automate behaves. The model reasons over the evidence, but the tools provide the evidence. Fourth component is the planner. Planner decides what should happen next. Behave. This can be simple. It does not need to be a giant autonomous brain. In many production systems, the planner is a controlled workflow. Collect input, enrich context, evaluate risk, draft next action, validate output, stop, approve gate. The important part is sequence. Mission behaves. If the agent drafts a ticket before checking ownership, the ticket may go to the wrong team. If it behaves, it recommends remediation before checking maintenance windows. It may create operational risk. If it checks exploit intelligence after ranking priority, the ranking may be wrong. Planning is how the agent avoids doing useful steps in the wrong order. Also helps with brand. It behaves. If owner data is missing, route to review. If threat intelligence times out, mark enrichment incomplete. If production action is requested, stop at approval. If confidence is low, do not pretend the output is complete. Automation was a good planner, makes the workflow predictable enough to trust and flexible enough to handle changing conditions. Fifth component is guardrails. It behaves. Guardrails define what the agent is allowed to do, what it is not allowed to do, and where to stop. This is especially important in cybersecurity. That's an agent that summarizes findings is low risk. An agent that drafts a ticket is higher risk. Agent that changes production systems is much higher risk. Those actions should not all live under the same permission level. A real agent needs boundaries outside the prompt. The prompt can say, do not take unsafe action, but a production system should also enforce permissions, approval, gates, tool restrictions, audit logs, and policy checks and behaves. For example, a vulnerability triage agent may be allowed to normalize findings, enrich context, draft a remediation ticket. Automation behaves and prepare an approval request, but it should not approve production remediation by itself. Automation behaves. That boundary should be enforced by the system, not trusted to the model's good behavior. Behaves and guardrails are what turn agent autonomy into controlled autonomy. Sixth component is validation. Behaves. Validation checks whether the agent output is good enough to trust. This is the layer many teams skip. Behaves. They look at the final answer and ask, does it sound reasonable? But sounding reasonable is not the same as being correct. Automation behaves. A validator can check whether the output includes required evidence, whether every claim has a source, whether confidence automate behaves is appropriate, whether missing data is clearly marked, whether the recommendation matches policy, and whether the next action, in a vulnerability triage workflow, the validator might ask, automation behaves. Did the agent cite the scanner finding? Did it verify the asset owner? Did it check exposure? And behaves. It check exploit intelligence. Did it detect any missing context? Did it stop at the approval gate? Automation behave. The answer is no. The output should not move downstream as if it is complete. Behaves. Validation is the difference between polished output and reviewable output. Put the 6 components together. A critical finding arrives for internet-facing VPN gateway. The LM explains why the finding matters. Behaves. Memory loads. Prior context, the asset belongs to network operations. Similar findings were routed there before. And production, remediation requires approval. Behaves. Tools pull scanner details, asset inventory, exploit intelligence, ticket history, and maintenance windows. The planner decides the sequence, enrich the finding, confirm exposure, check exploit status, draft a ticket, prepare an approval packet, and stop before execution. Behaves. Guardrails prevent the agent from directly approving or applying remediation. Automation behaves. The validator checks the final packet, evidence and confidence stated, policy respected, missing data marked, and next action point. That is a real agent workflow. How the automation behaves, not because the model is magical, because the system around the model makes the work controlled, traceable, reviewable. The takeaway is simple. A real AI agent is not a prompt with a tool attached. System. Automation behaves. The model gives you reasoning. Memory gives you continuity. Tools give you access to workflow state. Behave you sequence. Guardrails give you control. Validation gives you quality. Mission behaves. Miss one of those layers and the agent may still look impressive in a demo. Production is where missing layers show up. Behaves. No memory becomes inconsistent behavior. No tools becomes advice without action. No planner becomes random automation. No guardrails becomes unmanaged risk. No validator becomes confident output nobody can trust. Automate behave. So before you ask which model should power your agent, ask a better question. What system surrounds the model? Automation behaves because that is what determines whether you are building a real agent or just a better chatbot with costume.